Thanks for coming to my session about securing your AI stack. A little bit of background. So I've spent the last 18 months as the cyber AI leader in the US for Deloitte. I've had sort of two responsibilities. One has been to build systems to transform the way we deliver services to clients. The other side of it has been building new solutions to take to clients as part of the solutions that we sell. So as part of that, I spent quite a lot of time building AI solutions for the last 18 months, and we've learned quite a bit. And so that's what I'm going to be sharing today when I go through the slides, and we'll talk about one of the actual use cases that we've built and a lot of the technology integration and other things that went into that. All right. So quick show of hands. How many folks here are developers? Okay. Data scientists? Okay. Cyber people? Oh, wow. All right. Peeps. I'm glad you showed up. How many of the developers are actually working at the intersection of cyber and development? Okay. Got a few. Right on. All right. Well, we want to see more of those as we go forward because that's going to be key, and I'll talk a bit about that today. So go ahead and jumping in. So 20 minutes is going to go pretty quick. We're going to focus on answering 3 questions. What do you need to think about when you're thinking about security risk as it relates to AI? The second one is, what does a secure platform look like? And the third one was, the security process look like for securing basically an AI solution or workload? Okay. All right, so this is Deloitte's trusted and secure AI framework. There's multiple frameworks out there. This one is ours. It's publicly available on our website, etc. If you want to get further details on this, by all means. We'll also be in room 259 if you've got questions after the session too, so bear that in mind. But basically, when you're thinking about building an AI solution, you want to make sure you're covering off on the primary risk domains associated with AI workloads, right? So the first one being safe and secure. That's obviously directly related to securing the system. We'll talk about some of the risks for a number of these. I'm not going to read all of them because 20 minutes does go pretty quickly. But I'll highlight some of the ones, and we're obviously going to focus more on the security, but we'll touch on some of these other topics today as well. So the second one is around making sure the system is private, the solution is private, protecting privacy, obviously important. Transparent and explainable. Data scientists, that's very familiar to you, something you've been dealing with for a long time. Fair and impartial. Increasingly important when you think about bias and the implications of bias, not only in providing wrong answers, but also providing answers that could get you into regulatory trouble and other aspects. Responsible, right? Being used in a responsible fashion. Accountable, to make sure it's clear who's responsible for the outputs of the system. And then lastly, robust and reliable, right? Making sure it's, it's resilient and it continues to operate. When we think about some of the risks from a security perspective, we're thinking about things like secure vulnerabilities, right? These have existed in code for a long time. That's not new. We are thinking also about prompt injection, jailbreaking. That is somewhat new, right? So we've been doing forms of injection for a long time. Prompt injection is just a new form of how you can submit, language into a machine and get an answer that was not designed to give you. Model inversion or evasion is another new one, right? More familiar to the data scientists in the crowd, but we're going to talk about how those, has to meet up within the model development lifecycle. And then obviously deepfakes being something that's commonly churned out by AI and increasingly an issue at an enterprise level. I'll quickly touch on, private. You're really looking at data loss or compromise as one of your key concerns. You obviously, inappropriate use or risky system access would be things to be concerned about there as well. Jumping down to responsible, I'll highlight toxic or harmful content as being one that people are familiar with. But it's really, I think, we're going to focus if you want to maintain an accurate, reliable, and brand-worthy system. We'll talk about that a bit. And then robust and reliable, you can talk about poor user experience, hallucination, obviously, and then model instability or drift is one that I don't think gets enough attention. Because if you develop a model and leave a model, it's going to go wrong eventually, and so you really need to be managing that in a way that traditionally data scientists have thought about, but developers haven't necessarily thought about the same way. All right, so I'll go ahead and jump in to the next slide. So when you think about those risks and you think about the controls that you need, what does a secure platform then look like, right? In the center you've got, basically this is your AI solution or workload. Generally you're going to have developers on one end who are both doing model development, test, and deployment, data, design and ETL. You're going to have the model layer, the data integration layer, and the data layer. Then you're going to have an LLM typically in there, then the application layer, input and output, and then your consumers of the solution on the other end, right? So you do need to secure all this, and we're going to get into a use case on the next slide about what that looks like. But specifically, you also have to have kind of the platform around it. And so it starts with programmatic AI governance, right? This is these are traditional concepts, right? So if you think about it, AI strategy, operating model, training and awareness, policies and procedures, and compliance. These are not new topics. We've thought about these things a long time. They have to be adjusted to deal with the realities and some of the challenges unique to AI. So one of the things we make a point of telling people is that it's likely you have some of these things in place in your organization today already as part of your SDLC, other programs. Don't duplicate, don't create a new process, don't overlap, right? You want to modify the processes you have to be most efficient. So you're probably adding things to your existing process as opposed to creating a new one. So AI lifecycle management, right? That's really about secure ML ops, DevSecOps, and secure supply chain. AI testing, model validation will probably sound familiar to some of you. Stress testing, red teaming is increasingly a requirement, increasingly going to be necessary, and it's going to have to be done in an automated fashion, basically in real time going forward. So it won't be like a human doing it once a quarter kind of thing, which is what most organizations probably have. We need to be thinking about this in a much more active way. Explainability, I think you guys are familiar with that. Trust operations, this is really looking at all the input, output moderation, as well as the model and app monitoring. And then down below, you've got data quality, privacy, and safety. So data protection, guardrails, data governance, data privacy, et cetera, and then platform security. So some of the traditional stuff the security folks will be used to around logging, monitoring, access control, cloud and network infrastructure security, abuse and integrity testing and monitoring, and so forth, right? So if you're developing an AI solution, that's great. If you don't have this around it, you've got a problem, right? And again, you're looking at modifying the way you do things today, not whole-scale changes, hopefully. All right. Getting to the next slide. All right, so this is a specific use case that we've worked on. So I'll give a little bit of background on it. So as part of our go-to-market offerings, Deloitte came up with a new service. It's an AI factory service, basically. Silicon to service is the terminology we use. It's basically where we bring in an entire stack of technology, all the hardware, software optimized, and we manage it on behalf of a client. You do it on-prem, do it in the cloud, et cetera, so they can focus on building their use cases, not focus on doing all the infrastructure integration, ongoing operational management of that technology, right? So as building that solution, we built the security component into it, right? And going through the process, learned quite a bit by testing different commercial tools, evaluating how effective they are, looking at the integration points, running into all sorts of trouble along the way. So it was good time and good learning. And so from that, we've outlined on the slide at a quote high level, is the flow of how we look at the workflow of the application as well as the cyber overlay on top of it. So that's a very key point. So if you want to really secure an AI solution, you have to get down into the actual exchange of data all the way through the pipeline, all the way through the system. And you have to look at the security controls you have embedded at all the different points of exposure. That's the only way to do it properly, right? So as we think about that, that means you're looking at everything on the front end before it goes, everything coming inbound and outbound and in between. So this particular use case is divided up into three primary kind of components of the application. The first there is client data, right? So that's where the raw streaming data is coming from. You've got the ingest factory, which is where we're doing all the secure collection, validating, and transformation of the data. And then you've got over here the query factory, which is where you support the real-time batch querying, inference, interaction with the AI models, et cetera. So fairly kind of standard approach in that regard, right? This was built to allow lots of use cases on top of it, so it follows a fairly generalized pattern. So as we get into it, you're looking at the workflow or the flow of the application all the way around, and that's where these numbers correlate to on the slide. I won't read it all because, again, 20 minutes goes quickly, but I'll just kind of walk you through. So at the front end, you're looking at the inbound query. You're sending that through, in this case, Nemo guardrails. We're also using an AI firewall on the front end. We found that a layered approach works better because each of the individual products are good at certain things, but they're still not good at everything, and some products are better than others at a given issue. All right, so we ended up layering things in order to get the kind of coverage we were looking for. That's going to be true for a while, right? And we'll get into some of the kind of the issues as to why that is the case. So then it's getting passed into Nemo, going back and to and from the LLM model, going into the retriever, vector DB, back into the data, and then back all the way out. So again, we're looking at all the input and output in each of the steps in between and looking at the security controls to protect the data in transit, right? Does that make sense? Cool. All right, so what did we learn from this? A few things. So if you walk away with anything, nothing else today, please, look at this slide. So vulnerabilities that you absolutely positively have to address. There's more, by the way, but we're focused on the big ticket items here and the things that are pretty common. So the first one is improper output and hallucination handling. So you really have to be looking at the output because that's the way you know, obviously, something has gone wrong and what has gone wrong specifically. A hallucination in the case of a chat with, any of the large LLMs about how insurance works, not so bad. A hallucination as to whether or not something is an actual cyber attack or a false positive, that's a deal breaker, right? If there's any hallucination at all, that system doesn't work, right? So you really have to be focused on this and getting the quality and the accuracy up to meet the needs of your use case. Second one there, around prompt injection. There's different forms of this, but fundamentally the idea is using prompts to break down information either that's not meant to be exposed or breaking down information about the system itself that allows an attacker to eventually work their way in, be able to take over the system or gain access to data, sort of traditional things we've worried about from a security perspective, but they're just happening through a different vector. Okay. System prompt leakage. This is when your system gives away information about how it's prompting, which makes it much easier for someone who's attacking the system to do either number one or number two, right? Because you're basically informing them how the machine works. The more they know about it, the faster they can break it down. Sensitive information disclosure, clearly, don't want to see SSNs, right, going out the wire. We're going to talk about why real-time monitoring is so important, or near real-time monitoring is so important to prevent these types of things from occurring. But you actually have to have that visibility into everything that's going through and when it goes out. So ideally, you're blocking it before it goes out the door, but if it does go out the door, then you'll quickly respond. So toxicity and bias. So obviously, toxicity probably being more of a brand issue these days, right? Bias being potentially significantly more. So bias can obviously cause things to go very wrong from a data science perspective. Again, you could underwrite the wrong thing. You could make the wrong choice or different decision on a business transaction. But it can also step into the world of regulatory issues when that bias gets into certain spaces dealing with consumers and so forth. Unbounded consumption. This can happen through accident. So you've designed a system that spirals off and starts consuming more and more GPU time and other things and eventually causes a performance degradation. It can also happen through what we would typically call denial of service attack, where someone forces that to happen by prompting repeatedly, providing a lot of data in their prompt and doing other techniques to bring it down. The other issue that comes along with that oftentimes is cost. So when a web app, gets denial of service, you're usually not looking at a big cost implication. If someone can cause the GPU cycle to spike and run for an extended period of time, for those who are paying those bills, that can get really costly really quick. So again, something to stay on top of. So as we think about these, the ones on the left really imply the statements on the right? What are some of the required capabilities you have to have? The first one there is around basically end-to-end security for the interaction of the data and the models, right? Again, if you don't have that, then you're exposing or you're going to leave yourself open to risks because you won't have the visibility that you need, and you also won't be able to prevent some of these things from occurring. We'll talk about agentic at the very end. This just gets, I'm a cyber guy, so I'm going to say it gets worse in the agentic world, right? The story does not get happier. So this is really important to focus on. The next one there, protecting against modern day LLM attacks. That's pretty obvious. That's probably more a commercial tool today, but there's nuance around that, which we'll talk about in a moment. And then near real-time alerting and blocking of what's happening within the solution itself to address some of the things we talked about in terms of prompt injection or output going out the door that sensitive and unintended, et cetera. So a few kind of takeaways from the work and the testing that we've done. So the first one is configuration complexity across environments. So building secure AI solutions in the cloud is, it's complex. Building them on-prem is probably more complex because of legacy technologies. Building solutions that run in the cloud and on-prem, so hybrid, is the most complex scenario. And so that's proven to be, I think, fairly challenging. So just know kind of what your strategy is and what you're getting into. Typically, the skill sets you need once you get into the hybrid side are pretty strong around containerization, network, container networking, and so forth. And those skills usually don't sit in the cyber team. They usually sit someplace else in the organization. So again, that's when it comes to the collaboration aspect is really important because today, I'm just curious, I'd raise the hands. I mean, how many of the folks who are cyber in here have someone who does data science on their team? Okay, I think that's 3 hands, right? So today, data scientists are probably often the revenue generating part of the business. They're not necessarily allocated to cyber, right? You find the same thing. So on the application teams of this, teams are providing a service, that's usually where your container gurus are. They're not typically made available to cyber for doing this kind of work. The next one there, limited out-of-the-box coverage. So commercial tools will cover the kind of the major LLMs, common APIs. But if you have a custom stack, they're probably not going to protect some of the elements that you are using, right? And if you're using kind of, less popular technologies, they may not have built coverage for that. So you really have to look at the commercial tools and figure out how much of it will actually cover in your environment. The last point on here is that when it comes to, sort of vulnerabilities, they actually are model dependent at the end of the day, right? So we build these systems, but we also attack these systems. We get permission, we get paid to do that. So as part of that, we have people who are spending their time figuring out how to prompt a model from a subject matter perspective in order to create, an operative, basically exploit a vulnerability, right? So a generalized commercial security tool is not going to do that for you, right? They just can't. They can't apply to every single different situation that's out there. So they go for the ones that have the largest use. All right, data loss prevention. Kind of obvious based on probably some of the other comments, but you want DLP coverage for your entire environment, right? And when I say entire environment, I mean, you probably think about that at an enterprise level, but for the most part, you're probably starting with an enclave when you're thinking about trying to build this kind of capability and protect it, right? Transferring your entire corporate network to match the architecture we were looking at earlier would be ideal in the long run, but it's probably a longer term effort. So again, think about this as how can you isolate the environment? How can you protect the network separate from the rest of your corporate enterprise network so you can gain the level of control and visibility that you're looking for? All right, the last one on the right there is need for robust data tagging. So data tagging is not super complicated, but it's a pain in the ass, and I find that most companies don't do it, right? And so if you're not tagging your data, you're not going to be able to take advantage of the capabilities and the cloud platforms and some of the security tools to actually leverage and protect when you think about granular policies, when you think about encryption, when you think about other aspects of securing the data itself. If you're not doing, mature data tagging, those capabilities are not going to work for you. All right, so policy customization is labor intensive, so the commercial tools will cover, sort of out of the box, certain aspects of what you're doing. You'll probably have to create your own rules to protect the models in more detail, when you think about that, if you've got 10 rules per model and you've got 100 models, you're in the business of writing custom and maintaining custom security policies. So you need to think about this upfront in your design, because if you do use a very kind of unique combination of tech, you're going to be doing a lot of this on your own. All right. Visibility gaps in model runtime behavior. So there are guardrails that are looking at inputs and outputs, and they're generally available in a lot of different places. You can get them from the cloud providers, you can get them from open source, et cetera. But a lot of those don't have visibility into actually what's happening inside the machine itself, right? So they're just looking at the prompts and they're looking at what's being returned, but they don't see the runtime behavior. So they can't tell if something's happened after the prompt's gone in and there's other activity occurring, such as one agent receiving a prompt and going and talking to another agent that it shouldn't, but it's been prompted to do so, right? If you don't have that runtime visibility, you won't know that's a problem. And again, in the agentic world, that's a huge issue. All right, last one there, robust access control is required. So again, how many have worked on identity access management in their careers for the cyber crowd? Like it's been a thing for a long, long time, still not great in a lot of companies. And so this is a really crucial, you're gonna have to get to granular understanding of access control in these environments in order to, particularly again, we'll talk about in a second about agentic. It's gonna be pretty core. All right, so I'll hit the next slide. Okay, so I mentioned how the teams are sort of not necessarily connected in all cases, and I want to sort of draw a point around that. A couple minutes. All right, I'm gonna have to move quick. So this is an example model development lifecycle, right? Again, for the data scientists in the room, you already think this way, right? But for the security folks and the developers, you may not. But what's happening here is typically you don't worry about the weeks at the top. Those are just estimations. But basically you're doing your initial feasibility. Can you really do it? Can you make the model work? Do you have the data that you need? You're testing out your theories and discovery, figuring out how you're going to make this work, what's the right technique to use, et cetera. You're doing your model development and so forth. Ultimately, you're doing your acceptance. So you do your testing and evaluation to make sure you're achieving the outcomes that the model's intended to do. And then the last step, you got deployment and support on an ongoing basis. Pretty standard. You have to build security into that process. That's what this row is down here. And I'm not going to run through all of it because I'm going to run out of time. But it's critical that you have the data science, the development, and the security team working together, right? So for the systems that we build internally, we have all those people on a single team for each team. We've deployed them in pods, so each pod has all skill sets covered. And that's how we're tackling it, because otherwise you get too many handoffs and things get lost. All right.
All righty. Thank you so much. Let's give it up, everybody, for Mr. Kieran Norton.
Appreciate it.